Welcome. This is an overview and demonstration of the new features included in V1.3 of the Unity IO Assigner, a Unity Pro productivity tool. There are 3 more videos which also demonstrate V1.3 use. These provide additional details related to the use of the Unity IO Assigner with specific use scenarios. References to these videos are included. This is a list of all of the new features contained in V1.3, and I will be demonstrating these highlighted new features in this video. To put this in a real-world perspective, I will demonstrate the Unity IO Assigner using this MODICON M340 system architecture. It includes a CPU with Ethernet, an NOE Ethernet module with Modbus TCP IO Scanner capability, and a couple of X80 IO modules. There are also 2 distributed IO racks, which each use the MODICON M340 Peripheral Remote IO Adapter, or BMXPRA, and each also includes X80 IO modules. For the DIO drops, the Unity IO Assigner will be used to assign variables to the X80 IO module channels, auto-generate Modbus mapping of the I/O channel's data, and auto-generate DDTs and structured variables for the master M340 NOE IO Scanner interface. And for the master M340, the Unity IO Assigner will be used to assign variables to the local X80 IO module channels, auto-generate Modbus mapping of the local I/O channel's data for access by an HMI or SCADA system, and auto-generate DDTs and structured variables for the master M340 NOE IO Scanner interface. To prepare for this demonstration, I have created the M340 hardware configuration, added the NOE IO Scanner entry for the BMXPRA. This is a good time to reference one of the other videos, Managing Unity Pro Projects containing BMXPRA DIO drops. Check it out to learn the details. Next, I launched the child Unity Pro instance for DIO4. Then I created the DIO4 BMXPRA hardware configuration, saved the DIO4 project, and exported the DIO4 project for use with the Unity IO Assigner. And on with the demo. But wait, it is cool to know that included with the Unity IO Assigner installation in the examples folder is all of the content to be demonstrated, and this content will be used in the demonstrations. So I will set the path to the examples content. Also, it is cool to know that you can easily explore the example content, and aspiring to be cool, I will do that now. And now it's time to see the Unity IO Assigner used with the BMXPRA project exported ZEF file for DIO4. I load the ZEF file for DIO4. From the explored examples content, I will open an Excel spreadsheet that contains the I/O channel definitions for DIO4. I will copy the contents and paste the clipboard into the Unity IO Assigner IO Variables pane. This results in the auto-assignment of the variables defined in the spreadsheet to the I/O channels of the hardware configuration based on the type definitions set in the options. With that done, let's check the feature demonstration list. 2 of the new features have been demonstrated, and now another. V1.3 includes variable viewing and reporting. And here you can see the I/O variables that have been added from the pasting of the Excel spreadsheet content. I will be using this feature again later in this demo. Checking the feature demonstration list again. And moving on. Generating a Modbus mapping interface is not new for V1.3, but doing it for M340 and M580 local I/O is. So here is how that is done. Simply choose the %MW address to use for the array DDT. Click Add Modbus Client Interface to Unity Project. And then Done. But before I click anything, Know that you can review the section of logic created in this GUI. Here is the code that will be automatically generated. Now, I will click on stuff. Click, 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 click. Here you can see the added variable, and it can be expanded to display the details. To understand how the generated interface works when using the array DDT setting, see the video Implementing MODICON Ethernet Remote I/O with the Unity IO Assigner V1.2. Once again, checking the feature demonstration list. And again, moving on. For the Modbus mapping, what's new in V1.3 is the option to generate the interface variables as structures instead of arrays. To demonstrate this, I will reopen the Generation GUI. Notice that the menu item is green, which indicates that the mapping has already been generated. I will do some more clicking. Click, 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 and review the differences between the variables created as the array DDT versus the structured DDT. Here is the structured DDT expanded in the variable report GUI. The arrow is pointing at the first element generated for the DAI module in rack 0, slot 1, which within the structure is defined as a word. Here are the 8 defined bit extracts, because the module has 8 channels. And the first 4 have been defined by the variable names with comments as assigned to the first 4 channels by the previously pasted XL data. The last 4 elements or channels are assigned an appropriate name to hold the space for future assignment. Now let's look at the differences in the logic created. Note that the status variable now identifies the variable name assigned to the I/O channel of the module. Another check of the feature demonstration list, and another moving on. The next what's new in V1.3 related to Modbus mapping is the ability to reserve future capacity into the Modbus mapping %MW address space, and this is how it is done. I have reopened the Generation GUI, and the future reserved words are set here. I have set it to 8. The result is the addition of a new element into the generated DDT and variable with the name future, and the element is created as an array of 8 words. Including future reserved capacity allows the previously assigned %MW addressing to be maintained when new I/O modules are added into previously empty slots. When the Unity IO Assigner is able to maintain the previously assigned %MW addressing, it is indicated here. If a system is in the development phase, then loss of the previously assigned addressing may not have consequences. But if the system was already put into service and communications with the Modbus mapped interface is functional, then any changes to the defined interface could result in the need for significant rework to Modbus clients that are using the interface. In this real-world example, the client is the Master M340, or it could be HMIs or SCADA. This is another good time to reference one of the other videos, Tips and Tricks for Using the Unity IO Assigner. It contains examples of reuse of the Unity IO Assigner and how the future reserved capacity is used and affected. One more check of the feature demonstration list, and one more moving on. Before I continue with the remaining new features, let me review what has been accomplished so far. In this real-world MODICON M340 system architecture, the Unity IO Assigner has assigned variables to I/O channels and created a DDT and variable that defines and links the I/O channel data of DIO4 to the IO scanner of the Master M340. The next thing needed is for the Master M340 to be able to control the outputs in DIO4. I will demonstrate how to do this. I simply check the box for Modbus clients will write directly to all local output channel values. Please understand the warning and see how the logic is now created differently. The code for all output modules has been reversed. The next thing needed is to separate and consolidate the output modules into their own DDT and variable. This will provide a %MW addressed space for the master M340 I/O scanner to write the control for the outputs. This is done by simply checking the box for Include I/O Outputs DDT Interface. And I will do that now. The first thing to point out is the now visible I/O Outputs DDT Interface settings and variable. The second thing is the warning because there is an address overlap with another existing %MW located variable in the Unity project. I will first fix the address overlap. Within the Modbus mapping GUI, I can view the Unity project %MWs used. Assigning the new I/O Outputs DDT variable to %MW16 is possible. So I will do that. Taking a quick look at the effect of adding the I/O Outputs DDT variable to the generated logic. The output is now equal to the status variable, which is equal to the new %MW address assigned to the I/O Outputs DDT variable, which will be written to by the master M340 I/O scanner. Now I will include 8 future reserved words into the I/O Outputs DDT variable, then add this Modbus client interface to the Unity project, and finally save the DIO4 ZEF file. While I execute the clicks, it is cool to know that when the checkbox for the Include I/O Outputs DDT interface is checked, the Unity IO Assigner will also generate an importable XSY Unity variables file, and I will demonstrate importing this file into the master M340 project shortly. Now let me review the accomplishments again. This real-world MODICON M340 system architecture has an interface for the master M340 IO scanner to read the status of all the I/O in DIO4, which was auto-generated and includes the auto-assigned variable names for all the I/O, and write the control to all of the outputs in DIO4. This was also auto-generated and includes the auto-assigned variable names for the output I/O. Here is the master M340 NOE IO Scanner configuration. And now, checking that feature demonstration list one last time. I have demonstrated all of the highlighted features, but I am not done yet. I need to get the Unity IO Assigner produced content for DIO4 into the Unity project for the real-world MODICON M340 system. So in the child Unity Pro instance for DIO4, I have closed the DIO4 project, opened the DIO4 ZEF file created by the Unity IO Assigner, built the project, saved the project, and exited the child Unity Pro instance. This puts me back into the master M340 project, where I will import the Unity IO Assigner generated XSY file that contains the DDT and variable definitions for the DIO4 IO status and control interface. Before I execute the import, make note of the master %MW zones assigned to the NOE IO Scanner configuration. I right-click, click on the Variables node of the project browser and select Import. Here is the XSY file created by the Unity IO Assigner for DIO4. In the data editor is the imported variables, and I will assign these into the master %MW zones for the NOE IO Scanner. And expand elements of the structured variables to show the details for the BMX DRA output module in slot 2. Now I have a working system where all logic and I/O control will be executed in the master M340. The BMX PRA in the DIO drops is a controller, but as demonstrated, does not contain any code. The example content includes several exported DIO4 files. Each was exported at an incremental point in the development of the working solution. The final DIO4 export does contain example logic for including fallback output control in the event that the communications with the master M340 is lost or if the master M340 is taken out of run. The last video to reference is designing systems to use a mixture of X80 EIO and X80 DIO. This video and its content contain additional examples of including logic in BMX PRAs. The example includes hardware and application diagnostics logic. Check it out to discover more tips and tricks. Thank you for your time, and as always, I hope you have a great day.